Good morning, everyone. I will report you the three famous mathematician and under contribution. First, Scaro. Born in February 6, 1464 in Bologna, or now is also known as Italy. Died at November 5, 1526 in the Papal State, or is now called Italy. Stephen del Piero was an Italian mathematician who is famous for being the first to find a formula to solve a cubic equation. Del Piero is sometimes known as Ferriu, sometimes as Ferro, and sometimes as Dal Piero. His role in the history of mathematics is an important one, and he deserves great credit for solving one of the outstanding ancient problems of mathematics. In one sense, he is well known for his role in solving cubic equation. Is explained in almost every general work on the history of mathematics ever written, and yet, surprisingly, his name remains relatively unknown. Del Piero parents were Floranio and Filipa Pero. Floranio Pero was employed in paper making, which, because of the invention of printing in the 1450s, became an important trade at this time, due naturally to a vastly increased demand for paper. Of Ezekiel del Piero's education, little is known, but it is probably that it was at the University of Bologna, which was founded in the 15th century, 11th century, and so was a long-established and famous university for 100 years before Del Piero was born. The standing problem which Del Piero solved was to find a formula to solve a cubic equation similar to the formula which had been known since the time of the Babylonians for solving quadratic equation. Today we write the solutions too, and that's the equation of Del Piero. In Del Piero's first time, although such solutions were known, they were not known in this form. Firstly, in the middle of the 16th century in Europe, zero was not in use. Secondly, negative numbers were not in use. And thirdly, there was no understanding of a quadratic having two roots. Mathematicians in the time of Del Piero know that the problem of solving the general cubic could be reduced to solving the two cases, the equation and that equation, where m and n are positive numbers. The term in x cubed can always be removed by means of a suitable substitution. Of course, if negative coefficient had been in use, then there would have been only one case. Second, Carl Friedrich Gauss in 1777 to 1855. John Carl Friedrich Gauss is sometimes referred to as the Prince of Mathematicians and the greatest mathematician since antiquity. He has had a remarkable influence in many fields of mathematics and science, and is ranked as one of history's most influential mathematicians. Gauss was a child prodigy. There are many anecdotes concerning his precocity as a child, and he made his first groundbreaking mathematical discoveries while still a teenager. At just 3 years old, he corrected an error in his father's payroll calculation, and he was looking after his father's accounts on a regular basis by the age of 5. At the age of 7, he is reported to have amazed his teachers by summing the integers from 1 to 100. Almost instantly, having quickly spotted that the sum was actually 50 pairs of numbers, which is per summing to 101 total 5,050. By the age of 12, he was already attending gymnasium and criticizing Euclid's geometry. Guess theory. Although he made a contribution in almost all fields of mathematics, number theory was always Gauss' favorite area, and he asserted that mathematics is the queen of the sciences, and the theory of number is the queen of mathematics. An example of how Gauss revolutionized number theory can be seen in his work with complex numbers, combinations of real and imaginary numbers. A complex number such as a plus bi, where I is the square root of -1, can be represented graphically using a real axis and an imaginary axis using the imaginary unit I. The imaginary and real numbers together form a plane known as the complex plane, and that's the relative of complex numbers. Case gave the first clear expositions of complex numbers and of the investigation of functions of complex variables in the early 19th century, although imaginary numbers involving the imaginary unit equal to the square root of -1 had been used since as early as the 16th century to solve equations that could be not be solved in any other way, and despite Euler's groundbreaking work on imaginary and complex. This is the line of best fit by guess let's squares method. The method allows a summary of our works. For much of his life, Gauss also retained a strong interest in theoretical astronomy, and he held the post of director of the astronomical observation on Göttingen for many years. When the Plenitude series was in the process of being identified in the late 17th century, Gauss made a prediction of its position which varied greatly from the prediction of most other astronomers of this time. But when Ceres was finally discovered in 1801, it was almost exactly where Gauss had predicted, although he did not explain his methods at that time. This was one of the first applications of the least squares approximation method, usually attributed to Gauss. The third last as John Napier. John Napier contribution to mathematics. Napier devoted most of his leisure to the study of mathematics, particularly to devising methods of facilitating computation, and it is with the greatest of these logarithms that his name is associated. He began working on logarithms probably as early as 1594, gradually elaborating his computational system whereby roots, products, and equations could be quickly determined from tables showing powers of a fixed number used as a base. Logarithms were meant to simplify calculations, especially multiplication, such as those needed in astronomy. Napier discovered that the basis for his computation was a relationship between an arithmetical progression, a sequence of numbers in which each number is obtained following a geometric progression from the one of immediately preceding it by multiplying by a constant factor, which may be greater than unity. Example, the sequence 2, 4, 8, 16 or less